cool. Let's look at an attempt to solve the inequality x to the 4 minus 2x squared minus 3 is less than 0 by completing the square. Okay, again, this is a very classic TMUA question, right? They give you a random proof and then you have to find if there are any flaws in it, yeah? So option A is completely correct, and then option B till, I don't know, option how many, to option G, yeah, is asking you to find where the error is. All right, okay, so let's do this. Let's have a read of the proof. So I have this inequality here. So first line, is it okay? What did he do? He added 4 to both sides. I think that's perfectly fine. Yeah, because adding 4 to both sides, you don't have to change the sign of the inequality. Fine. Okay, and then from line 1 to line 2, he used the perfect square identity to factorize. Yeah, so that's just factorization, right? So there's nothing to do with the inequality itself. So there's no way that is going to go wrong, I think. Okay, how about next step? Is this correct? Something squared is less than 4 means that that thing itself is between -2 and 2. Is that correct? I think so, yeah. He's very diligent to have put the lower bound as well. Lots of students make this mistake, yeah. They just square root both sides and ignore the lower bound. But this student is very diligent, he put the -2 down there as well. That's very, very important, yeah. So that's correct still. Okay. And now he somehow removed the lower bound though. I literally just said that he was very good at putting a lower bound there, and then now somehow he removed it. All right, is he correct? Let's have a think. Well, in fact, in this particular scenario, he is correct there. Yeah, he could remove the lower bound because the lower bound will be satisfied no matter what, right? Because the minimum of x squared is 0. All right, so if the minimum of x squared is 0, then the minimum of x squared minus 1 is -1. So no matter what, all right, no matter what value of x you pick, you will be greater than -2. Yeah, so the lower bound is automatically satisfied, so technically you could just get rid of it. Remember, this is a special scenario, yeah? Remember, when you take square roots in the inequality, make sure you put the lower bound there first before doing anything. All right, okay, so line 4 is still okay. How about line 5? So we added 1 both sides, okay, again, nothing too special, so that's also okay. I added 1 to both sides. And then to line 6, same thing, right? When you take square roots, remember to put the lower bound there. The lower bound must be there. Yep, so it seems to me that this is perfect. I think this is quite correct, yeah, from my view. So I would say the answer should be A. Yeah, the argument is completely correct. There we go.